In section 5.2, we're going to take everything that we've learned so far about rates and unit rates and now look at some real-world application and word problems that might involve rates and unit rates. Our goal is by the end of this section to be able to solve problems involving rates and unit rates. If we take a look over here at our vocabulary, we're continuing to use our understanding of rates and unit rates within this section, and we're also going to be adding in this understanding of speed. Speed will come a little bit later on, so we're going to hold off on talking about speed for right now, but keep that in mind as something that we are going to work on here. Let's take a look at Learn 1 to start. So, in Learn 1, our job is to be able to solve simple word problems involving rates and unit rates. So given number 1, a machine can pack 70 boxes of spaghetti in 5 minutes. That is a rate. So just like we know how to write rates, we have 70 boxes in 5 minutes. The question is asking us, at this rate, how many boxes of spaghetti can be packed in 8 minutes? Similar to our understanding of ratios and drawing our bar models in section 4.3, we have to think about, well, I know I can pack 70 in 5 minutes. My goal is I want to figure out how many boxes are going to be in 8 minutes. I can't quite go straight from 5 to 8. But maybe I can figure out how many boxes can be packed in 1 minute or find our unit rate, and from that be able to solve for 8 minutes. So let's first start by finding a unit rate. So to do that, remember we take our top number divided by our bottom number. When we take 70 divided by 5, we find that 14 boxes can be packed per minute. So again, that is our unit rate. But our question's asking us to find then how many boxes can be packed in 8 minutes. So if we know 14 can be in 1 minute, we now need 8 groups of that. So we're going to take 14 times 8 to find that 112 boxes can be packed in 8 minutes. So with any kind of word problem set up like this, where you're starting with a rate and then it's asking you to find maybe how many boxes or some other amount given the second amount, we can always draw back on our unit rate and use that to solve for any other unknown amount. Moving on to Learn 2, we're now going to be taking a look at some tables filled with information to be able to solve some multi-step rate problems. So in problem number 2, the table shows the parking rates at a parking garage. We can see that over here, that the first hour is free, the second hour is $1.75, and then any hours after the second hour is going to cost $2.50 per hour. So Ben parked his car there from 9 a.m. to 2 p.m. on the same day. Our job is to find how much he paid for parking. Okay, the first piece that's going to be helpful to us is finding out, well, how many hours was he parked there? From 9 a.m. to 2 p.m., that would be a total of 5 hours. So we need to figure out how much it's going to cost him or how much he paid for 5 hours. So hour 1, according to our table, is going to be free. So that's $0. Hour 2, according to our table, is $1.75. And then every hour after the second hour is going to be $2.50 per hour. So we have 3 more hours to do. Hour 3, hour 4, hour 5. And each of those is $2.50. So we have our amounts for each hour. If we think about how we're going to solve, is we really are going to add all of these together. Okay, so I have 0 plus 175. Well, that still equals $1.75. I have 3 groups of $2.50, so I can add 3 groups times $2.50 and find my total. $1.75 plus 3 groups of $2.50. Altogether, Ben paid $9.25. Looking at problem 3, continuing to use a table here given to us to find the amount paid for a situation. So the table below shows the charges for renting a bicycle. Tom rented a bicycle from 10 a.m. to 2 p.m. on the same day. How much did he pay for renting the bicycle? So similar idea. The only difference is our table's giving us different amounts. So for the bike, for the first hour is going to be $3. And then for every additional half hour, it's going to cost $2.50. So if this is for 30 minutes for a half hour, it might be helpful for us to figure out, well, for 1 hour, what the rate is. If a half hour is $2.50, if we multiply that by 2, we know that 1 hour is going to be equal to $5. Especially since when looking here for the amount of time he was renting the bike, we're not really going to be using that half hour. We want to work with whole hours. So from 10 a.m. to 2 p.m., that's a total of 4 hours. If I think about what we have here for each hour, so hour 1, according to the table, he's being charged $3. And then every additional hour is going to be 5. So for hour 2, hour 3, and hour 4, each of those hours he's being charged $5. We can either add all of these up together, or we can think about this as $3 plus 3 groups of 5. And when we add and multiply that all together, we find that his total is $18. Moving on to Learn 3 and looking at comparing unit rates given a multi-step word problem and situation. So in problem 4, Andy needs new batteries for his video game controller. He is trying to decide between 2 brands. A package of 2 brand A batteries costs $3.20. The manufacturer claims that the batteries will last 20 hours. So for brand A, we know it costs $3.20 and it's going to last for 20 hours. A package of 2 brand B batteries costs $2.80, and this manufacturer claims that the batteries will last 14 hours. The question's asking us to decide which battery Andy should buy, and then think about why your answer is what it is. So, in considering this situation, we want to compare our hours of battery life to the dollar, figuring out how many hours of battery life per dollar each brand of battery will receive. Because for $1, we want to get the most life out of that battery as helping us find which one's going to be the better buy. Typically, we've thought about as dollars per hour, but for this situation, we're going to flip-flop that. So for A and B, let's find our unit rates of hours per dollar. For A, we have 20 hours for $3.20. When we divide, we find that it's going to last 6.25 hours for $1. We're going to do a similar thing in brand B where we take our 14 hours, divided by our $2.80. And when we divide, we see that brand B will last 5 hours for every dollar. So looking here for a dollar, if he's going to spend $1 with brand A, he's going to get more time, more battery life than he would with brand B. So brand A is going to be our choice because there's more battery life per $1. Moving on to our next learn, now we're incorporating speed, distance, and time using unit rates and rates given to us. So in problem 5, Mr. Lobbins drives his truck at a speed of 45 miles per hour. In part A, at this speed, how far will he travel in 2 hours? So over here to the side, this triangle is going to be super helpful in deciding whether we're going to multiply or divide. So given the speed and given the time, we're trying to solve for distance. So if we're trying to solve for distance, I can see here my formula. For distance, I need to take my speed times my time. So in part A, I'm going to take my speed times my time to find that Mr. Lobbins travels 90 miles. In part B, still with this same speed, we want to find how far he travels now in 5 hours. So I'm going to use my same formula. I'm still figuring out my distance. So I need to take my speed of 45 times my time of 5 hours. When I multiply these together, I get 225 miles. Looking at the next problem, Alex ran around a soccer field at a speed of 8 meters per second. How long did it take him to run a distance of 96 meters? So in this problem, we're given our speed and we're given our distance. If we're given our speed and our distance, we're solving for time. In this triangle, I'm going to divide. So I don't know my time. I'm comparing my distance and my speed, so I'm going to divide here. Distance divided by speed is going to give me my time. So let's take our distance of 96 divided by our speed of 8 to find that our time is going to be 12 seconds. Looking at the next problem, a van traveled 280 kilometers. In 4 hours, find the speed of the van. So according to my triangle over here, now I'm going to be solving for speed. My relationship between distance and time is that I'm going to divide these to be able to find my speed. So for speed, I take my distance divided by time. So 280 divided by 4 gives me 70 kilometers per hour. If we take a look at what speed really is, speed is a perfect example of a real-life unit rate where we're comparing a distance per 1 unit of time. In the next one, a car travels 1/4 kilometer in 1/2 of a minute. Again, we're solving for our speed, so we know we have to take our distance divided by time. So I'm taking 1/4 divided by 1/2. We have to remember our dividing fractions rules, our keep, change, flip. We get 1/4 times 2/1. We multiply across, we get 2/4 or 1/2. So the speed is 1/2 kilometer per minute. Moving on to the last learning objective, finding the average speed of word problems. When we think about what average speed is, this happens where maybe an object is traveling over a distance where the speed might not always be the same. For example, when a bike slows down when it goes up a hill, or maybe then it speeds up as it goes down a hill. In finding the average speed, we're trying to find how fast the bike might have been traveling overall. So given the next problem here, the distance between town P and town Q is 80 miles. And then we have a distance between town Q and town R being 320 miles. So it's going to be helpful for us to maybe visualize this. So we've got our three towns. We have P, Q, and R. Our distance between P and Q is 80 miles. Our distance between Q and R is 320 miles. If we continue to read, a van takes 2.5 hours to travel from P to Q. And then it takes another 5 hours to travel from Q to R. Our job is to find the average speed of the van for the whole journey. And what we use, our formula for finding our average speed, is to take our total distance divided by our total time. So given this visual here, we can see our total distance would be 80 plus 320, which is 400 miles, divided by our total time of 2.5 hours plus 5 hours, so 7.5 hours. And now we can divide and solve. 400 divided by 7.5. If we plug that into a calculator, 400 divided by 7.5, we end up with a repeated decimal of 53.3 repeating. So we put our repeating bar over our 3, and this is miles per hour. So the van travels an average of 53.3 repeated miles per hour. And the last problem to continue practicing average speed. Sienna ran around a 400-meter track 2 times. It took her 4 minutes to run around the track once and 6 minutes to run around it again. And we're going to find her average speed. So again, our average speed equals total distance divided by total time. Her total distance, she's running around this 400-meter track 2 times, so her total distance is 800 meters. Her time, she runs 4 minutes and then 6 minutes, which makes 10 minutes. That now we can divide and find that she runs an average of 80 meters per minute.